All right, P4 Polynomials, Day 2. So here we're just going to perform operations with polynomials and several variables. So we're doing the same thing we did in Day 1, but now what if there's more than one variable there? What if there's an x and a y? All right, so a polynomial in two variables, x and y, contains a sum of one or more monomials of the form of ax to the n, y to the m. So what this is saying is that we're going to have more than one variable. We can have a number in front, and both of the variables can have exponents. So we could have like 2x to the third, y to the fifth. Okay? Or we could have 2x to the third, y to the fifth, plus 5xy. All right, so it's just got two variables, which both of them can have exponents, and it has to be a number in front. And it can be one or more terms. So the constant a is the coefficient. That would have been my 2 or my 5. The exponents are n and m, which will be whole numbers. Now, here's where it changes from yesterday. The previous lesson. The previous lesson only had one variable, so we only had to worry about that exponent when we were looking for the degree. So we were like, hey, it's the largest exponent. But now we have more than one exponent because we have more than one variable. So the degree of each monomial, so each term is what they're talking about here, is when we add the exponents together. So like right here, this term would have a degree of 8 because 3 plus 5 is 8. This term would have a degree of 2. That's each term, okay? Then here it tells us the degree of the polynomial in two variables is the highest degree of all the terms. So the degree of this entire polynomial here is the larger of those two. So which was bigger, 8 or 2? The 8 was. So therefore the degree of that polynomial would be 8. All right, so we're going to do the same thing we did before. We're going to add and subtract. We're going to combine like terms. So let's look at this. Just like before, we've got to get rid of the parentheses because we are subtracting. And so we're going to put our 1 there and distribute it. Remember, 1 doesn't change anything, so we get x cubed, negative 4x squared y, positive 5xy squared, and then minus y cubed. And then here we're going to distribute the negative 1, which remember, that's just going to change the sign. So we're going to get a negative x cubed, positive 6x squared y, and a negative y cubed. Now we're going to combine our like terms. And so now when you have more than one variable, don't worry about so much standard form, okay? Technically, it's the variable that's listed first in descending order and the second variable in ascending order. All right, but I'm not so worried about that. Just make sure you can solve it. So we've got x cubed, and I have a negative x cubed. I have a negative 4x squared y. So do I have any other x squared y's? I do. I have a positive 6x squared y. Then we have a positive 5y squared. I'm sorry, 5xy squared. Do we have any other xy squares? We don't. So I've got negative y cubed. And I have another negative y cubed. So now we're going to combine our like terms. So x cubed minus x cubed. Remember, add or subtract the numbers in front and then keep the variable the same. So 1 minus 1 is 0. So there's 0x cubed, so it cancels. We're not going to write it because there's none there. Then we have a negative 4x squared y plus 6x squared y. Negative 4 plus 6 is 2. Keep your variables the same. Then we only had this one term that was 5x squared y. So I didn't have anything to combine it with, so just bring it down. I think I said that wrong. It was 5xy squared. And then we have a negative y cubed minus y cubed. So remember, that's negative 1 minus 1, which is negative 2, and keep the variable the same. And so here is our solution. And then we're going to multiply. We're going to do this the same way. Notice there's only two terms. Even if I had variables here that were together, look for your plus or minus signs to find your terms, okay? There's a minus sign, so there's two terms on this one. There's a minus sign, so there's 2 terms on this one. Don't get confused because you're going to see one, especially on your assignment, that's like x squared, y squared. I don't remember if it's plus 3 or minus 3, something like that. This is a term, that is a term. All right, don't separate the x squared and the y squared. They're together there. All right, so let me erase that, and then we'll continue on this problem. All right, so we're multiplying, so I'm going to make my box. I know it's going to be 2 terms times 2 terms. And I'm going to make mine a little bigger because I write big. All right, and so we're going to put 7x minus 6y and 3x minus y. We'll multiply, so 3x times 7x is 21, and then remember, keep your x, add your exponents. 3x times negative 6y, positive times a negative is negative, 3 times 6 is 18, and then I have an x and a y, put them in ABC order. Negative y times 7x, a negative times a positive is negative. I only have the number that's a 7, and then I have a y times an x, so we'll list them both in ABC order. And then the last one, negative y times negative 6y. Negative times negative is a positive. We just have the 6 as a number, and we got y times y, which is y squared. So we have 21x squared minus 18xy minus 7xy plus 6y squared. So then we combine our like terms. So 21x squared. Here's my like terms. What is negative 18xy minus 7xy? Negative 25xy. And then keep your plus 6y squared. And there is our solution.